Equations of lines. Now here we have different forms. The first one is point slope form. This is like y minus y1 is equal to m times x minus x1. So you're given with one point, and the point that we're looking at is this one here, and given with the slope. Remember, m is our slope. Again, m is our slope. And that's the rise over run. Again, that's the rise over run. And then we have the slope-intercept form. That would be y is equal to mx plus b. Where m is the slope, b is the y-intercept. Now for vertical lines, this is in the form of x is equal to a. So one example for this is just like x is equal to 1. So it means that when you draw the graph, you have y-x here, again y-axis and x-axis. Just find the value for x, which is 1, and the line should be crossing at that point. So that should be vertical line, which is x is equal to. Now, it's similar to horizontal line. You will have like y is equal to a. A is a constant term, and example would be y is equal to 2, and the graph would be like this. So find the value for y, which is 2, 1, 2, and the line should be crossing at that point. So the point is 2, and the line should be passing there. And that would be your y is equal to 2. So that's the line, which is horizontal line. And then you have the parallel lines. So when you see parallel lines, the M1 and M2 are equal. And perpendicular lines, it means M1, the first slope, is equal to the negative reciprocal of the second. Okay, so those are the terms used in this section. So we will make summary for all those formulas. And I believe there will be one more form that our equation of lines can be. So, and that would be the standard form. The standard form has a formula ax plus by equals c. So note that all the variables is on the left side of the equation, the x and y, and then the constant is on the right side. So that's the standard form of an equation. Okay, so this is for, again, equations of the lines. let's make a summary for all those formulas. So we did a summary last time on the previous section, so we'll make a summary again. So if you're talking about lines, you're talking about slope of the line, which is actually equal to m, and this is equal to rise over run. So this is the steepness of the line. So how inclined the line is. So it could be positive, it could be negative, or it could be m is equal to 0, or m is undefined. So we can do the Mr. Slope guy as our guide for this. What I said a while ago, when the line is going up, that's increasing, the slope would be positive. If the line is going down, the slope is negative. And when the line is vertical, the slope m is undefined. So that's the u there. And when the line is horizontal, m is equal to 0. Okay, so let's form a face. Okay, so that would be Mr. Slope guy. Now, the first formula for slope would be m is equal to y2 minus y1 all over x2 minus x1. We call this two-point slope form. Okay, so think about this is the first ordered pair here, x1, y1, and the second ordered pair it's at x2, y2. So the numbers here are just subscripts. So do not put this as a power like y power of 2. Y squared is different with y subscript of 2. So those are just indicators. That's the second point. And that's the first point. So that's what it means for 2 and 1. And then that's solving for m. The next one is having the equation of the line. That would be y is equal to mx plus b. Okay, so we know what is m, that's the slope. B here, it's the y-intercept. B, it's y-intercept. So this is the intersection between the y-axis and the line. So that would be the point or the ordered pair. So we call this equation as slope-intercept form. Okay, the third one, it's having 2 points here. So y minus y1 is equal to m times x minus x1. So you're given with 1 point and a slope. So we call this as point slope form. Okay, so these are the only 3 formulas we need in solving slope problem. And then plus this information about parallel lines. So when you have parallel lines, the two lines are equidistant to each other and never cross to each other, or it will not intersect with each other. So the relationship between the first slope of the line and the second slope of the line would be equal. So M1, that's the first slope, equal to the second slope. So that's how we know that the two lines are parallel. And then we have the condition perpendicular. Lines. So when the two lines crossing each other, forming like a cross, like a rectangular coordinate system, like the x and the y, and it forms 90 degrees angle. So in this situation, our M1 here is equal to the negative reciprocal of the second. So negative 1 over M2. Or if you cross multiply this equation, you can get the product, which is M1 times M2 equal to negative 1. So if ever you multiply the two slopes and it will be equal to negative 1, the two lines will be parallel. The last situation would be neither. So it's not parallel, it's not perpendicular. So the line is crossing to each other, but they are not forming 90 degrees. So again, they are intersecting with each other, but they're not forming 90 degrees. Okay, so that's the third condition. So if it's not parallel and it's not perpendicular, your answer would be neither or neither of the two conditions. Okay, so let's apply those formulas with an example. So example, given two ordered pairs, and you're asked to find the slope. So if you're asked to find the slope, you're going to use the first condition or the first formula. That would be m is equal to y2 minus y1 all over x2 minus x1. Note that you can interchange which would be your point 1 and point 2, so it doesn't matter. So always label your points. You can have x1 here and then y1 here, or you can do it on the other point. So it's just going to be the same as long as the other would be your second point. So this would be our x2 and this would be our y2. And then we just apply or plug in the values. Y2, applying the formula, that would be 0 here minus our y1, which is 2, all over x2. x2 is 3 minus our x1, which is a negative. So be careful with the sign. This is a negative 1 for x1. Okay, and then calculate. It gives us negative 2 over 3 minus negative 1. It's 3 plus 1. So that should be 4. So it's a negative 1/2, reducing the negative 2 over 4 into the lowest term. So that would be our slope. So it's a negative. So it means if you're going to think about graphing this, the line should be decreasing. It's going down, something like that. Remember the Mr. Slope guy. if that is negative. If that is positive, it's increasing, it's going upward. Okay, so that's how you know. And if that is m is equal to 0, that should be a horizontal line. And if m is undefined, it would be a vertical line. Okay, so next, um, you're going to be asked, find the equation of the line. Now remember that you cannot find the equation of the line without the slope. If you don't have the given slope, then there's no way for you to find the line until you're going to solve for the slope. So these 2 points, the two ordered pairs are given. So we solve for m, which is our first question, find the slope. And then if you're asked to find the equation of the line, you can just use formula 2 or formula 3. So let's try using formula 2. Y is equal to, or let me see, that should be y minus y. Okay, so let me erase this one. Okay, so I'm trying to use the second formula. So this is the third formula. So I will write that out again. The second formula is y is equal to mx plus b. Okay, so we can actually find that equation by plugging in our x. We have our x here, and we have our y. So doing that, we can use the first point, where y there is 2. And then our m, we know our m is negative 1/2. Then our x would be negative 1. And then what we're trying to do here is finding our b. Okay, so our answer now would be 2 is equal to a negative 1/2 times a negative 1. So that should be a positive 1/2 plus b. Solving for b, I will move my 1/2 from right to left, becomes a negative. So that's 2 minus 1/2 here. So therefore, my b is 1 and 1/2. Or that would be 1 and 1/2. Or that would be 3/2 in mixed fraction. And then we plug that into the equation. So we will have now y equals our m. We know our m, that's negative 1/2. And then x here, then plus 3/2. And this would be the equation of the line. So again, this is using formula 2. So we're using formula 2 here. And using formula 3, you can still solve the equation of the line. So we will do the alternate solution here. Alternate solution. So this is by using the third formula. So using the third formula, you can actually solve the equations. So you're going to have y minus y1 is equal to m times x minus x1. So that's the third formula. And then we plug in the values for the first point and the slope. So that would be y minus 2 is equal to our m, our slope is negative 1/2 times x minus our x1, it's a negative. Okay, and that is in point slope form. So that would be the equation of the line. So we can still simplify if you want to simplify that, but this one is already an equation of the line. But if you want to match our solution on the other one, because this is a different form, the first one is in slope-intercept form. The second one is in point slope form. Okay, so if you want to continue and you just have to simplify and let your y be alone on the left side. So simplifying, we will have, we'll just do a different color. Y minus 2 equals negative 1/2 x. So that will be positive there. That should be a negative 1/2 also there. And then we multiply the whole equation by 2 to eliminate actually we don't have to do that. We can actually try multiplying that, and it will give us actually the standard form. So that's another form that we're looking at. Okay, so we can continue and see if we will have that form. So by multiplying that, it cancels all the 2's at the bottom. So it gives me now 2y minus 4 equals negative x, and then that would be negative 1 minus 1. Okay, and then remember the standard form, we put x and y on the left side. So I will have now x here plus 2y equals negative 1. And that is plus 4. Because I moved negative 4 to the right side becomes a positive. So in standard form, the answer would be x plus 2y equals 3. So this is in standard form. So now, if you're going to have the slope-intercept form, the one that I mentioned a while ago, to check, then you have to just isolate your y. Isolating your y, then you will have something like this 2y. Just use a different color. So I'll go 2y, and then move my x to the right side becomes a negative x plus 3. I have to divide 2 to all of them. Then I will get my slope-intercept form, which that goes, we don't have space here. I'll just put my answer here on the top. So that would be y equals negative 1/2 x plus 3/2. So this one, it's in slope-intercept form, just to check and match this to the first answer. So there are plenty of ways to find the equation of the line. So you can have slope-intercept form, you can have the standard form, or you can have the point slope form. So those are the three. So it will be asked on the question, but if it's not on the question asked, then you can choose what form that your equation will be. So you can have, again, the slope-intercept form, the point slope form, or the standard form. So take note with our equation here. We're going to move on to letter C. Okay, so let's have letter C. Same problem, but different question. So letter C, you'll be given a point. So an equation. So the equation that we solved a while ago, it's y is equal to negative 1/2 x plus 3 over 2. And here you're given with another point. So let's say you have here negative 1, negative 1. So that's another point. And it says that find the equation of the line of the line that is passing through this point here, negative 1 comma negative 1, and parallel to the given line. So this is the given line. So again, the word parallel is here. So we know that when we see parallel lines, uh, the definition from the one that we made a summary a while ago, M1 is equal to M2, right? Okay, and we know that this is our M1. So finding that equation that is parallel to the given line passing through this point here, negative 1 comma negative 1. So finding that equation, you will just apply the third formula, which is y minus y1 is equal to m times x minus x1. And then here's our x1 here, and this is our y1. Now, since m1 is equal to m2, so I will have my m here the same, exactly negative 1/2. If this one is perpendicular, you take the reciprocal. So I'll make a note on this side. If this one is perpendicular, your m2 would be the negative reciprocal of the first. Our first is negative 1/2, so the negative reciprocal would be a positive 2. So if that is the question asked, you're asked about perpendicular, not parallel. So your M2 would be 2, and you plug that into the equation there instead of negative 1/2. So here we have negative 1/2 because it's parallel. And then our x1 is negative 1. And then our y1, it's a negative 1 also. So our equation is y plus 1 is equal to negative 1/2 x plus 1. So this is in point slope form. Okay. Most of the question asked on the test, it's actually finding the equation in slope-intercept form and sometimes standard form. Okay, so if we want to show what would be the equation of the line, if it's in standard form, then you have to multiply this by 2 to eliminate the 2 here. So we will try that. So multiplying this by 2, the whole equation, it gives us 2y plus 2 negative x, because 2 cancels out. So negative 1 times x is negative x. Negative 1 times positive 1, it's a negative. standard form, the x and y should be on the same side of the equation, and then my constant should be on the right side. So plus 2 should be moved to the right side, becomes a negative 2. So x plus 2y is equal to negative 3. So this is in standard form. Okay. And then if you're asked to find this in slope-intercept form, you just have to continue. Then isolating your y, so I will just go 2y is equal to moving my x to the right side. I'm looking at the standard form equation. Minus x here is equal to, or minus, it should be minus 3, or negative 3, okay? Because they are on the same side. And then I divide 2 onto all of them. So y is equal to negative 1/2 minus 3 over 2. It's my equation for the slope-intercept form. Okay? So those are the 3 different forms. So either of those would be your answer. So you can actually use the first one as your answer, and the second one or the third one. Okay? It depends on the question asked. So if it says find the equation of the line, it doesn't say what form. But sometimes they will say find the equation of the line in standard form. So you have the answer here for the standard form. So you stop there. So, but if it's in a different form, we've shown you the different forms. So just follow the direction. Um, I'm trying to fix my answer here. I'll just miss my x here. So that's negative 1/2 x minus 3 over 2. So that's coming from the top solution. So I just missed my x there. So it's y is equal to negative 1/2 x minus 3 over 2. So that should be the one that's parallel to the equation y is equal to negative 1/2 x plus 3 over 2. And then it should be passing on that point, negative 1, comma, negative 1. Okay, so let's try and check our answer if we did the right thing by graphing. So we will actually know if we did the right thing. Okay, let's put the point here. The point we're talking about is negative 1, comma, negative 1. Let's label that. So you can see the label. So remember, we plot the x coordinate and the y coordinate. And the first line that was solved, and it was given on letter C, that would be 1/2 x, half x plus 3 over 2. Okay? And the other one that we solve is parallel to this line and passing through the point -1 comma -1, and that would be 1/2 x minus 3/2. So it should be negative, right? So we missed the negative sign. It should be a negative. Okay, so right there. So it should be pointing downward because the slope it's a negative. So as you can see from the graph, uh, it's true. The blue one is the first line that we calculated. So given the 2 points earlier, and we are asked to find that line given the 2 points. And then solving the last problem on C, which is finding the line that is parallel to the first line given the line and given a point. So that point should be along the line that is parallel to the first line. So that would be the second line. So that's y is equal to -1/2 x minus 3/2. So as you can see, those are the parallel lines, and it actually matches the problem asked. So, and you can see the green line, it's the line that's what we're looking for. And the line should be passing through the given point, -1 comma -1.